Good evening, everybody. Welcome to the Tuesday evening space show program. I'm your host for the evening, David Livingston, and thank you very much for tuning in. Most interesting discussion coming up with Bob Zubrin. Probably all of you know who he is, but he does have the Mars Society. He's probably the greatest proponent of getting to Mars now rather than maybe sometime in an undefinable future. He's got great engineering, great technology, great ideas. We're fortunate to have Bob back with him. Participating with us so far is John Hunt, Dr. Sherry Bell, Phil Swan, and Marshall Martin, as well as myself. Uh, Please remember that we are a 501c3 nonprofit. We are listener supported. So if you like us, please do support us. So you can find us on our website, thespaceshow.com. Look in the upper right corner, you'll get PayPal, which does Zelle and PayPal, and an address for checks. And for those of you tuning in through Substack, they have their own fundraising system. And you know how to do that for Substack. But we do appreciate your support. And we're great to have Bob with us. And you should be following his op-eds and editorials that he publishes on the Mars Society and elsewhere. And he makes a lot of news, and deservedly so. And his Mars Society conference is par excellence. And we're happy to have him on board. And Dr. Kathari over here just joined us. Bob, welcome back to the program.
Thanks for inviting me.
We've seen Artemis go up and around the moon and on the way home. And at the same time, that's pretty terrific. We are seeing a proposal to gut NASA science again and sort of defer and push out plans to go to Mars. So I'd love for you to give us an assessment of the situation, because I don't know how to assess something like this.
Well, one cheer. Okay. NASA, for the first time since 1972, has sent humans beyond low Earth orbit. And the Artemis program, which was initiated in 2017 by Trump, has finally actually had a flight of sorts. So identifiable progress. On the other hand, well, first of all, this flight can be compared in certain ways to the NASA Apollo 8 flight, when NASA first sent astronauts beyond low Earth orbit. But in fact, it was a less ambitious flight than Apollo 8, because Apollo 8 didn't fly by the moon. Apollo 8 orbited the moon, 10 times, and then came back. This was a single free return. So from a mission design point of view, this was a less ambitious mission than Apollo 8, significantly less. More to the point, Apollo 8 was followed within 7 months by landing on the moon with people, because Apollo 8 wasn't just a one-off and with no follow-up ready. The guns were loaded to follow Apollo 8 with, first there was another one where they went into lunar orbit, and they actually got into the LEM and went part of the way down to the moon and then back up. And then finally, they did the moon landing in July of '69. The Artemis is not in position to do a moon landing anytime soon, because one of the things that they don't have with Artemis is a lander, which is very useful if you want to land. In fact, in contrast, now this is not Isaacman's fault. Okay, this problem began with the first Trump administration and then continued in the Biden administration. That is the entire Artemis. Artemis does not have a coherent mission architecture, unlike Apollo. Apollo started with a imperative from the president to land men on the moon and return them to Earth before the decade was out. NASA then went off to conduct a plan, to develop a plan on how to do this. They eventually settled on the Lunar Orbit Rendezvous Plan. They identified, therefore, an overall design for a set of vehicles, basically three fundamental flight systems, namely the Saturn V rocket, the command module, which included the capsule for the astronauts, and the lunar excursion module. And these things were designed as a set. They fit together, and they enabled human missions to the moon. In contrast, Artemis is really 5 independent programs, each with a certain amount of support to develop 5 primary flight vehicles, which do not fit together. This, of course, includes the SLS rocket, which was used to launch this mission, the Orion capsule, the SpaceX Starship, the Blue Origin Lockheed Martin National Lander, and the Lunar Orbit Gateway. So they had 5 systems that really don't fit together. Now you say, okay, what? Wait a second. The Saturn, the SLS just launched the Orion. Yeah, but it doesn't have enough power to launch the Orion with enough fuel to get into lunar orbit and come back out again. So all they could do is a flyby. And one of the reasons for this is that the SLS, it doesn't even have a proper upper stage on it. The S2 on the Saturn V, that was powered by 5 J2 engines, and the S4B, the third stage, was powered by 1 J2 engine with 250,000 pounds of thrust. They should have had a J2 on the upper stage of the SLS, but NASA proved unable to redevelop it 50 years after it had been developed the first time, and because it was out of service in between. And so they put on, I forget whether it's 5 or 6 RL-10s, which together have maybe 120,000 pounds of thrust, half the thrust of a J2 all put together. And so it's underpowered. In other words, the upper stage of the SLS is not the right upper stage for the SLS. It's the right upper stage for a vehicle about half the size of the SLS. The Orion, on the other hand, is much heavier than the Apollo command module. Now, it does house 4 people instead of 3, but it went from 6 tons to 26. And so it's too heavy, and the SLS is too weak. And so you can't even get the capsule into lunar orbit with enough fuel to come home, let alone the capsule and a lunar excursion module together into lunar orbit. So it can't do the mission. Okay. Then they have a completely separate launch system, the Starship, which, if it can be refueled on orbit, could go from low Earth orbit to lunar orbit. And if it could be refueled there, it could go to the surface and back up again and even back to Earth. And in fact, this is the mission architecture that SpaceX proposes, and it requires no less than 14 Starship launches to get one Starship from the surface of the Earth to the surface of the Moon and back again, because the Starship has to go into Earth orbit. That's one launch. Then it will take 3 more tankers to get it to from low Earth orbit to low lunar orbit. And then you have to have 3 more tankers delivered to low lunar orbit to refuel it to go to the surface and come back again. But each of those tankers, in order to get to low lunar orbit, needs 3 tankers to fuel them in Earth orbit. And so it's 14 launches. So that's Musk's one-size-fits-all mission plan, which makes no sense. The Starship could be an excellent heavy lift booster to take things to Earth orbit, because it has comparable capability to the SLS, but maybe 5% the cost. If you refueled it to go to low lunar orbit, you could get it there. But there, really, rather than trying to go to the lunar surface and up again, for which it's extremely suboptimal because it weighs 100 tons compared to the 2 tons of the Apollo lunar excursion module, you really need a lander. Now, NASA did give a contract for a lander after it gave the first contract for the lander to Starship, because the other side, the national team, was screaming that they really wanted a contract or they would hate NASA forever. So they gave him a contract, but the lander that they designed is incompatible with Starship because it uses a hydrogen-oxygen propulsion system instead of the methane-oxygen propulsion system that Starship uses. If NASA had insisted as a requirement that the lander use the methane-oxygen, then Starship could have been a tanker that you position in lunar orbit and refuel the little lander going up and down. That would have been a coherent architecture. But no, they made no such effort. Instead, since the imperative was simply to give a piece of the action to the national team, it didn't matter. Okay, and then you have the Lunar Orbit Gateway, which thankfully Isaacman has canceled, but that was the 5th element of this, which served no useful function whatsoever. And I called it the Lunar Orbit Toll Booth. It was a place, actually, if you had to go there before you went to the moon, it would increase the number of Starship launches needed to stage the mission. So the whole architecture makes no sense. They have no follow-on. Now, there were other problems with the Artemis mission plan before Isaacman, namely that a planned to do a mission once every 2 years. That compares to 2 missions to the lunar surface every year during the Apollo program once it got into swing. So 1/4 the rate, which really makes the missions absurdly expensive because really the cost of the mission is not the hardware, it's the team. And whether you fly 2 missions a year or 1 mission every 2 years, you got to keep almost the same number of people employed. So,
Bob, can I jump in with a question?
Yeah.
So what I was wondering was, you mentioned that the plan to refuel the Starship was to actually fly Starships out to lunar orbit and refuel it there. About a year ago, I had the chance to ask somebody working at NASA on this, who was presenting at a conference, about how they would get Starship back. And the person told me, this was after the conference, after he made the presentation, he said that the plan was basically to fuel Starship up in orbit around Earth completely, and then send it down to the moon, over to the moon, down to the moon, have it come back up, and then it was going to be abandoned in lunar orbit. It wasn't going to come back to Earth. Have you heard of like a different story on how that's all supposed to work that I have heard?
Yeah. No, that wouldn't work. The delta V to do 6 kilometers a second to go from low Earth orbit to land on the moon, and then another 3 to come back up. You can't do that physically. The Starship doesn't have that much delta V, even if it's fully fueled. You could fuel it in Earth orbit and go to lunar orbit, and then fuel it there to go back down and come back up. Okay. Or you could go one way to the surface of the moon and stay there. But to do all the fueling in low Earth orbit, that would still require 10 tankers if you could do it that way.
Oh no, my understanding was it was to take like 15, maybe probably 20 tankers, assuming I think they have 15,000 tons in the upper stage right now. So you'd be filling that up completely in orbit, was the plan, yeah.
1,000 tons, and
Okay.
each tanker can bring 100. So you could put 1,000 tons in it if you had 10 tanker launches.
Yeah, I guess in that with those assumptions, I don't think you could get it all the way to the moon surface and back again. I was assuming 15,000 tons of fuel in the HLS to make this work.
The Starship only holds 1,000 tons of fuel. That's how big the tanks are. And the Starship weighs 100 tons. So you can get a mass ratio of 10, which is great, but it's not enough to do 9 kilometers a second with methane oxygen. Can't be done. So
This is
they
for
would refuel it. So they were going to refuel it either in lunar orbit or at the gateway. That was another plan, which would make it worse, but which would give an apparent use to the gateway. Now, so I'll give Isaacman credit that at least he got rid of the gateway, but he still doesn't have a coherent architecture. And it's going to take some heavy lifting here because really the problem fundamentally with Artemis is that unlike Apollo was a purpose-driven program. Okay, Apollo spent money to do things. Artemis is a vendor-driven program. It does things in order to spend money. So you have these various elements that don't fit together, but each wants to have a starring role in the play. And so you try to write a play to give every kid in the school a part. And you come up with a mess that only the parents could love. Now, and that's basically it. Now, there's another problem here as well, beyond the difficulty with Artemis itself, which Isaacman has begun to solve, but has not solved. That is, he's eliminated one of the worst elements of Artemis, but he has yet to straighten it out. What they need is Starship plus Starboat. That's the right architecture for Artemis. Okay, get rid of SLS, do Starship, but not all the way to the lunar surface, just to lunar orbit, and then have a much smaller Starship type vehicle that runs on methane oxygen that can do the up and down and can be refueled in lunar orbit from this large Starship tanker. That's the right plan. And you could use the exact same hardware elements to support missions to Mars because the delta V to go from low lunar orbit to the lunar surface and back up again is 4 kilometers a second. The delta V to go from low Mars orbit and back up again is 4 kilometers a second. That's because the delta V going down is almost nothing and the delta V going up is 4. So the same vehicles essentially could do both. And so Starship plus Starboat gives you both the moon and Mars, but this requires taking a whole bunch of stuff that they have and saying this is just junk that we picked up, at garage sales in the course of our lives, but we can't use it to build a house. And you got to make a plan and build the things to implement the plan. You don't just buy a bunch of stuff and then say, how can I make a plan that uses this stuff, which is basically how Artemis has been done. But this, okay, so those are the problems with Artemis per se. But now there's another problem here, okay, which is that the same administration, which is pushing this Artemis very hard, says it wants to destroy the space science program. Now, there's a number of problems with that. One is, if they get away with it, they'll destroy the space science program, which frankly is the jewel in NASA's crown and one of the jewels in America's crown. Okay, that is, when this period of time is looked back on 500 years from now, the great art of the 20th and the early 21st century is not Jackson Pollock, it's Hubble's photographs. It is Voyager's photographs. Okay, it is the Mars rover's photographs. Okay, this first views of the universe as we broke out of the cradle. That's what people will remember from this period. These things are not just great science; they are celebrations of the highest ideal of our contemporary civilization, which is the search for truth through science. Okay, and these are proposed to be butchered. Now, that's wrong. That's a crime. Okay, even worse, it's a mistake. Okay, okay, because you see, the space program has been pretty successful over the decades because it has been nonpartisan. Okay, we've had of all the things in American politics, people can't speak to each other on issues like gun control and abortion and this thing and that thing. But the space program has been something that unites us, that has not been a partisan divide. But now here's the deal. Okay, who actually fills the ranks of the NASA space science program? Who are these astronomers and these planetary scientists who are principal investigators on the various instruments on the Mars rovers and so forth? These are university-based scientists. And guess what their politics are? Typically, left of center. Okay? So you have the flag patriots who revel in the achievements of the manned spaceflight program, and you have these liberal intellectual professors who participate in the space science program. So if you want to have a bipartisan supported NASA, you have both. Okay? And if you want to destroy this unity, you say, we're doing great things. We're doing our moon program, and sorry, we don't have enough money to do that science stuff anymore. Okay? Okay. And so what you're doing is you're putting the mark of Cain on Artemis, so that when the political winds change, and they will eventually, they always do, okay, the Democrats are going to have it in for this program. And even more so for the putative Mars initiative proclaimed by Elon Musk, who obviously has defined himself in rather partisan terms. This cannot be. We cannot have the human exploration program become the enemy and, in fact, the murderer of the space science program. If we want to have full national unified support for this program, the manned exploration program cannot be the enemy of the robotic exploration program. It must be the friend. So, in fact, what we ought to be doing, okay, is A, Starship plus Starboat as the architecture for both the moon and Mars, and thus, in fact, enabling humans to Mars, not in the distant future, in the never, never, but as really a coherent part, an immediate follow-on to human lunar expeditions. But the very first thing that these things could do, okay, given that even the Starboat has a much heavier landing capability than, like the Curiosity lander. Curiosity lander can land 1 ton on Mars. To be at all useful, Starboat would have to land 10. And probably.
So is Starboat like a better idea than your original Mars Direct mission? Like when you had that original idea, was that more optimal or less optimal than what you're talking about with Starboat right now?
Well, in my opinion, it's less optimal. However, it's if you already have a Starship, okay? In other words, when we did Mars Direct, we were starting with kind of a clean sheet. Certainly starships were not in the mix. So if you start from the premise that there's this thing called Starship, which can do the sorts of things that it probably will be able to do, going to orbit, being refueled on orbit, and then doing translunar interplanetary transfers, you say, if I've got that, what else do I need beyond that to enable human expeditions to the surface of the moon or Mars? Well, it's Starboat, right? So,
well, why not like the Earth return vehicle? Like that seemed like a good idea. Like you'd send a vehicle there in advance, have it fuel itself up, so you had low risk when you went there to come back.
We can do that also with this architecture. Okay, you would use a Starboat to land the stuff for ISRU manufacturing on Mars. and you would refuel it on the surface. In other words, being methane oxygen, well, on the moon, it would need to be refueled by the tanker. It could be partially refueled with lunar oxygen on the surface, not methane. You can't get that on the moon, but you could get oxygen on the moon. And that's most of methane oxygen, 77% by weight. On Mars, we could start out doing it all from orbit, just with the same stuff same hardware set we're using for the moon. But then that architecture could be greatly improved by the fact that you can make methane oxygen on Mars. And now everything gets much better. Now you have the capability for surface to orbit, orbit to surface elsewhere, back up to the orbit, refuel there, go down. You can do all sorts of things with that kind of architecture. But basically, where I'm going with Starship plus Starboat is I'm starting with the premise that there's this thing called Starship that exists. And if you have that, then how do you do the missions? Okay.
Dr. Zubrin.
And I think we're going to have Starship soon.
Dr. Zubrin, at least for the moon, I'm not sure about Mars because you got some aerodynamics there, but for the moon, I looked at simply what you could do if you reduce the height of Starship for a lunar ferry. And by my rocket equation calculations, you don't need a full Starship to be able to go from lunar surface up to EML1 and retrieve 100-ton payload and bring it back to surface. It was surprisingly small. It was something like 40% less the height. I know your Starboat, I think it was like within the fairing, so it was sort of a scaled down in all dimensions, but would simply a shortened Starship be the same thing as a Starboat?
Not the same thing. It's a move in the right direction. I would just go further in that direction. Sure, the Starship weighs 100 tons, and bringing that up and down from the moon is incredibly suboptimal. So you say you cut it in half, and now it's 50 tons. Well, that's better than 100, but it's still way too much. I would want to have something no more than 20, and preferably more like 10 as the Starship.
But if
in other words, you want to go a factor of 2 smaller than Starship for the ferry. I want to go at least a factor of 5 and preferably 10.
But would that reduce the amount of payload, cargo that you could take to the moon or Mars? And hence, would that reduce the speed?
No, if you want to take cargo, you could take a Starship and just go one way and leave it on the surface. That makes a certain amount of sense. You land a Starship on either the moon or Mars, and you have an apartment house sitting on the ground, right, and you don't have the penalty of trying to get it back up. The problem with Starship is not what it can send out. It's the fact that this thing is so big and you have to get it back up. And that's where the thing really becomes suboptimal. If you go one way, okay, you could, as I say, you have an apartment house on the surface, or you've got a tank farm on the surface, or you have a large supply of high quality steel and aluminum on the surface, all of which are useful. But to do sorties to the surface and coming back up, a much smaller vehicle is desirable.
Incidentally, I can't give details, but we do have some inside information that SpaceX, at least in the past, has looked towards sending Starships one way to Mars, asking what could be done with, a Starship staying on Mars. So I think that has been considered.
Well, one thing that could be done with a Starship going one way to Mars is carrying a robot expedition. That is, instead of landing one rover on Mars, you land 30, as well as 30 helicopters and a well-equipped static science lab in the Starship. So the rovers and helicopters can fan out in all directions to bring samples back to the lab and have them analyzed there. You could have this whole thing. Okay. And you see, if they went forward with that as their proposition, okay, we're going to validate Starship as a one-way cargo delivery system to Mars, which would be a great thing to help build a Mars base, sure. But we'll validate it first and foremost by increasing the effectiveness of our robotic exploration program by a factor of 100. Okay. And at that point, you see, the human exploration program, instead of being the enemy of science, becomes its best possible friend, which it should be. Okay. Yes, humans on Mars will enormously increase our ability to do science, but well before that happens, and you have to understand that people outside of our community are kind of skeptical about when that is going to happen. They say, but if I've got this capability of delivering 100 tons to the surface of Mars instead of one, which is what Curiosity Lander can do, my God, think of the robotic science I could do. And this is what needs to be done. These people, by their obsession and their viciousness, actually, in going after the science program because it's loved by people they hate, okay, they're undermining the entire space program, including the part they like, okay, because two can play that game. And
yeah.
And so this is really malicious. And I have to say that I have to criticize Isaacman on this one, because Isaacman told me before he became NASA administrator, and when the DOJ was proposing exactly these sorts of cuts last year, he said he opposed this, he would fight this, he supports the science program. And last week he was asked, in response to this year's Trump administration's attempt to push the same thing once again, a 50% cut in the science program, he said, of course I support it. What's that all about? Okay, that first of all is breaking his word, and second of all is cowardice, because he knows this is wrong. He knows it's wrong, and he should not support it. He needs to take a stand. Okay, he really needs to take a stand. And I don't buy this thing of, well, if I don't go along, I won't be around. He should not make himself the murderer or an accomplice to the murderers of the great NASA space science program.
Dr. Zubrin, I'd like to ask you your opinion. What would you place the odds of Starship delivering cargo to the surface of Mars in 2029 or 2031? If you'd be willing to hazard an estimate.
I think if Musk was to focus on it, he could absolutely do it in 2031.
Okay.
Marshall, did you want to say something?
Yes. One of the key things that I keep hearing over and over is Starship is 100 tons. And Elon has, well, first of all, he hasn't got the 100-ton unit even tested yet. So problem one. And in problem two, Elon's been talking about Starship version 4, which is supposed to do 200 tons. And you kind of take a step back and you go, is that possible? Of course, if it is possible, it changes the dynamics of the whole projections for not only the moon, but also for Mars.
Well, you're talking about the claimed payload of this more advanced Starship prototypes.
Yeah.
Look, at this point, I'm sticking with the numbers 100 tons to orbit and it only having an inert mass of 100 tons. I think it would be grand if he could accomplish that. Now, someday he or someone will accomplish more than that. Okay. But, you know, to even say you can do the lunar mission with all these refueling with 14 Starship flights assumes that the Starship doesn't come in heavier than it's currently anticipated and that its payload is at least as much as currently or recently claimed. Now, if he can do better than that, that's great. But so far, I think it's not a crazy, but somewhat generous position to say I think you can get 100 tons to orbit with this thing, and that it will only weigh 100 tons.
Mm-hmm. The next part is, do you think there'll be significant improvement over the Raptor 3 engine? Because rockets are based off of the ISP of the engines, and there is talk of a Raptor 4, and you kind of go, boy, that's pressing the physics, I think.
Yeah, you're right. Certainly he can make engines with higher thrust. Okay.
Mm-hmm.
But the ISP of methane oxygen is never going to be more than 380 in vacuum, and more likely 370. And of course less at sea level. The propellants, the combinations have certain amount of energy per unit mass, and that determines the possible specific impulse. And so, sure, it's possible to build engines that are higher thrust to weight, that have greater reliability and more reusability and throttleability and various other features. But the ISP is constrained by the chemistry.
But Bob,
Zubrin?
what is the plausibility of anyone in Congress championing what you're talking about, and something along the lines of what you're talking about take over and be prevailing in the direction NASA goes and Congress goes?
Well, what Congress can do, and actually did do this past year, was push back against some of these wrecking operations against the science program. Okay, that they were able to do. That about 80% of the wrecking operation cuts proposed by the DOJ last year were rejected by Congress. So that was good. But in terms of creating a coherent mission architecture for NASA, I don't believe Congress can do that. NASA leadership has to do that. Okay, NASA, this is what they did not do. Okay, and here, once again, I'm now going to the people before Isaacman. This is not Isaacman's problem, but they were presented with demands through the political system that a second lander contract be given out because the national team had sufficient political clout to demand that they get some money too. But what they could have done at that point is said, okay, we'll give you your money, but you got to build what we want you to build, which is this, because we have a plan, okay, and we will pay you to build the stuff to implement our plan. Instead, it was, okay, we got to give you money, we'll give you money. What do you build whatever the hell you want? And so the mission architecture is incoherent. Isaacman will see if he has what it takes to correct that. But on the one hand, he did have the courage to get rid of the gateway, which was a complete boondoggle.
Why doesn't Isaacman just get rid of the commercial providers for the lander altogether and get NASA to build the best possible lander for this mission and go with that? Maybe get it contracted out, but do the design and have an integrated plan.
They don't need
as you said,
do the design. They have to set the requirements.
Right.
Okay. That's where it is. Do we need something that will do this? It can't weigh more than X. It can't cost more than Y. And it has to be interoperable with the thing we're already funding, which is the Starship.
Okay. Or Orion. I'm talking Orion and SLS, not Starship. So I said get rid of Starship, get rid of
SLS. You got a problem.
Why?
Because it just ain't going to work. The Orion is too heavy for SLS.
Well, we could launch a lander on SLS, and you could launch a lander launch Orion on SLS, and then get the two to go down and get rendezvous in orbit.
Two SLS mission And actually, even that wouldn't work because the SLS does not have enough oomph to put a capsule in Orion capsule in lunar orbit with enough propellant to come home. That is why Artemis mission that we're doing right now didn't go into lunar orbit like Apollo 8 did. It couldn't. So, I mean, think about this. December 1968, okay, we weren't ready to land on the moon, but we had a system that could go into lunar orbit for a while and come back out.
I think you can get into a high orbit, right? Because that whole plan was for the Orion to deliver astronauts and have the lunar landers go down to the surface and come back up. So it's just a higher orbit, not the low lunar orbit.
It's a lot higher orbit.
But that's still the plan.
Okay, yeah, but it's not low lunar orbit. It's from an energetic point of view, it's almost not in lunar orbit. It's almost in lunar escape.
Yeah, but that's still the plan, right? Like
second from the surface instead of two.
Yeah.
That's big.
Yeah, it's still going to go there, be in a high orbit, rendezvous with a lander. The lander goes down, comes back up.
I mean, let's see how long that plan lasts. I mean, things are changing.
But because but here's the problem with that. That's why it's an expendable lander, because the Gateway was going to be in a high orbit, if you will, want to call it that. That is 3 kilometers a second to the surface, 3 kilometers a second. So that's 6 kilometers a second. You have to go up and back. And the only way they could do that was by having it be a staged vehicle with the expendable lower stage. Okay. If the node was not there, but in low orbit, which is only 2 kilometers a second to the surface, or 4 for the round trip, you could do that with a single stage, fully reusable. So that's why that architecture, which they were forced to go into precisely because the Orion and the SLS were not designed as a coherent set, but each doing their own thing. Okay, so the Orion was too big for SLS, as opposed to Saturn V was more powerful than SLS, and the capsule was smaller. Okay, so that's why Apollo worked and Artemis doesn't.
Bob, are you aware that Isaacman said that both Blue Origin and SpaceX begged to not have to use NRHO? Have you heard that?
I haven't heard that. I could believe it because
I've heard that.
No one would want to use it. The only people that would want them to use it, and there you go, begged. Why were they being pushed? Okay, they had to be pushed to demand. It was imposed on them, okay, against their will, because it was stupid. And the problem with the Gateway wasn't just that you're spending all this money on the Gateway, but once you had spent the money on the Gateway, you'd force people to use it, which makes everything harder. Okay, if they built the Gateway and people were free to choose how to go to the moon, nobody would go to the Gateway. But that would make NASA look stupid for having built a way station that no one wants to go to. Okay, so that's the thing. So, I mean, the architecture was crazy. Isaacman has partially rationalized it, but he hasn't completely rationalized it yet. And there's no connection to Mars, okay, where there would be a rational, coherent architecture. We have 2 important goals here, Moon and Mars. So you design a hardware set that does both, okay, and you can, okay, and in fact, you can do both efficiently. And that's not being addressed. Now, there's further problems with Isaacman. Okay, the good news is he's for space nuclear power. I'm all there, okay? The bad news is he's imposing it on a mission that doesn't need it, which is the Mars helicopter mission, okay? He says he wants to do a Mars helicopter mission. Good idea. The helicopters are much more mobile than the ground rovers, and now, we've proven that they can work, so we should go there. But he says he wants to do a Mars helicopter mission in 2028. which is ambitious but possible, but not if you require nuclear electric propulsion to get them there. And there's no need for it. The Mars helicopter mission can easily be delivered to Mars using current propulsion systems. Now, I do want space nuclear power. It's not needed for propulsion for either robotic or human Mars missions. It is needed for surface power for human Mars missions. It is very attractive for highly capable outer solar system missions. See, because nuclear electric propulsion does not get you to Mars faster than chemical propulsion. That's just bunk. Despite the fact that the ISP is 10 times as great, the thrust is like 1,000th as great. And so nuclear electric propulsion is kind of like a car that gets 100 miles to the gallon, but goes from 0 to 60 in a week. So it doesn't get you around town faster than an ordinary car. If you were driving across, from Alaska to Chile, it might pay because, by the time you got to southern Canada, you'd be going 60 miles an hour, fast as the rest of the cars, and now you'd be getting your 100 miles a gallon, doing fine. But if you were just going from one part of Alaska to another, it would take you much longer with that vehicle. And so that's why nuclear electric propulsion really comes into play when you're talking the outer solar system, where the chemical ballistic flight times are very long and where it has enough time to get up to speed. And furthermore, it can provide a lot of power when you're out there, and solar power is not really available in good quantities. So your Saturn probe with nuclear electric propulsion can have much more power available to it than anything powered by, solar power is unthinkable at Saturn, but RTGs or, anything like that. So now you can do high data rate science, you can do active sensing, you can use your electric motor to putter around among the different moons. That's all great. That's where we need nuclear electric propulsion, but we do not need it to get helicopters to Mars in 2028.
What about nuclear thermal propulsion? Can you say something about that?
Well, I'm a fan of nuclear thermal propulsion, but that is not in the plan. So that's going to have to wait. But nuclear power is needed on the surface for Mars and highly desirable on the surface for Moon. Because it's 24/7, etc., reliable, doesn't depend on the sun, isn't constrained by dust storms or anything of that sort. And here's the thing, because I'll tell you, I used to be a big fan of nuclear electric propulsion, and until I had a conversation back in the 80s with Kraft Erica, and he challenged me. He said, why do you want to put the reactor on the spacecraft? And the example he used was actually the moon, where he said, look, and at this time, no one knew that there could be water at the South Pole, but everybody knew there was oxygen in lunar rocks. Okay. It says, okay, you have an RL-10 engine, hydrogen oxygen engine, and it has a specific impulse of 450 seconds. But 6/7 of its propellant by weight is oxygen. So if you just bring hydrogen to the moon and get your oxygen from the moon, you get a 7-fold multiplier of the effective ISP of the vehicle. So now 7 times 450, well, that's 3,000. So you're getting an effective ISP of 3,000 seconds, but at high thrust, and you're not lugging around this heavy nuclear reactor with its shield on your spaceship. Okay. And what you're managing to do, okay, all the energy from the nuclear reactor is being turned into liquid oxygen, and you're integrating the power of the reactor over time. Okay, so, and the same thing is true of Mars Direct. That, in fact, is where I basically got the idea. that we would use nuclear power to get to Mars and back, but not by powering the spaceship, but by creating propellant that could power the spaceship. And so the energy that the reactor put out over 500 days in making methane oxygen propellant on Mars could be released in minutes in basically RL-10 equivalent engines running on methane oxygen. And so that is why in Mars Direct, we only need a 100 kilowatt reactor on the surface of Mars, where if you look at Franklin Chang Diaz's Mars plans, he needs a 10 megawatt reactor, which is to say 100 times the power to do the job.
Bob,
yeah.
let me ask you a question and take you back to the mission architecture, because I want to try to keep focused on what's near term. We have a human landing timeline of 2028, so put that into the mix and the mission architecture, and where are we?
Okay, you're talking human landing on the moon in 2028. Well, here's the thing. You can do a lunar mission with Starship or even SLS, Orion, and the National Lander, okay? But it's hokey, okay? You would need to do some kind of to get Starship to low lunar orbit requires lots of tankers and things. But now you got to do it again to deliver the lander there, and they get into the lander and they go up and they go down, they come back up. The lander now is useless, and I don't know, maybe Starship comes home with you. It's not an efficient, it's not a sustainable lunar architecture. So if you're just trying to throw together a landing, you could probably do it with some of these things that they have lying around, okay? But it's not a high capability system. It's very ad hoc. It will be very expensive for each mission. It's building a house out of parts you see lying around the neighborhood.
Bill?
Another question. Yeah. So Bob, I'm wondering, is there any architecture for going to Mars that's better than the Mars Direct architecture, or possibly an update to the Mars Direct architecture that you've come up with since you originally proposed it, such as, say, using entirely hydrolox for propulsion instead of methane propulsion or something like that? And if so, why compromise on that? That's what NASA seems to be doing, is compromising and trying to make everybody happy and coming up with ridiculous architecture. So why compromise on the best possible architecture if that's Mars Direct or whatever's newer?
Not the best architecture.
Okay, I'm not saying it was. I'm just saying, is there any example of one?
Okay, no, hydrolox is on Mars. You've got CO2 available for free by running a pump out on the atmosphere. And then you can electrolyze water from ice on Mars, and you get some hydrogen, but you don't have to store it as liquid hydrogen. You can react it with CO2 and produce methane. A methane molecule has 3 times the energy of a hydrogen molecule, so the tanks can be much smaller. It's also, 6 times as dense as liquid hydrogen. And much more storable. It's the preferable propellant. And I've argued this since, 1990. And people are finally beginning to see it. And not just Musk with Starship, which was made to run on methane oxygen because Musk wanted to do Mars, and he knew that the easiest good propellant to make on Mars is methane oxygen. But even other companies now are starting to switch to methane oxygen.
Back to my original question, that was is there a better architecture than Mars Direct, or is Mars Direct still the best?
In my opinion, I don't know it's the best, but it's the best I've seen.
Okay. So why not stick with that? Why not insist on doing the best? Well, why compromise?
Because the only reason is if Starship exists, the fastest way to get a capable hardware set that can do both the moon and Mars is just add a Starboat.
Can you think of any reason why NASA hasn't already done Mars Direct? Like, have they come up with some analysis that says it's not affordable or something like that?
No, just exactly the opposite. It's too affordable. The no, look, there was a certain period of time when Griffin came in, not as administrator, but before that as associate administrator for exploration. And he saw the merit in Mars Direct, and he had me go back to Johnson Space Center and said, you got to listen to this guy. They listened, and they came up with what they called the Design Reference Mission 3, which is the best NASA design reference mission. And it was a Mars Direct-ish mission plan. It was 3 launches per mission instead of 2. It was a crew of 6 instead of a crew of 4. It had more equipment and it had some stuff that it didn't need. But basically, it was a Mars Direct type plan. Direct launch to Mars, no advanced propulsion, no orbital constructions, none of that stuff. And long duration stays on Mars starting on the very first mission. They published that, but then the electric propulsion people started complaining that they didn't have a part in the play. And so that's the thing is whenever NASA proposes something like a human Mars mission, all these people show up for the first meeting. They'd say, we'd love to support you. Of course, you have to include us in your mission plan. And sometimes they get a little more aggressive than that and basically say, well, you can't do your program until you do our program. And they like to paint themselves as essential. And for instance, electric propulsion people, because electric propulsion can do very high delta Vs, whenever they do mission analysis for human Mars missions come up, they insist on high delta V trajectories. Okay. It's like
sounds pretty dysfunctional, to be honest. Like,
yeah.
Do you think Isaacman recognizes that?
Oh, I'm sure he knows that. And he was able to take it on to some extent in terms of Gateway, which was obviously an albatross. But I'll have to give him credit. He's the first NASA administrator who took that on. So yeah, I'll give him credit for that one. But he needs to go a lot further in rationalizing this thing.
Bob, what about surface systems, habitats, ISRU, growing food? I mean, where do we stand with that, and what would it take for us to have those systems by the time they're needed?
Well, there's okay. There's 2 levels of ISRU that one can discuss. There are things that are either necessary or very strongly beneficial for initial or early missions. And there are things that are necessary for settlement. Okay. And for instance, take one example, growing food. You don't need to grow food on Mars to do a human Mars expedition. Okay. You need to grow food on Mars to have a Mars city. Okay.
But what about the interim time of like a large and growing international base? I mean, I don't think
a large Mars base, you need to grow food.
Right.
Okay. I mean, that's, and obviously there's some point in between a large Mars base and a first landing where it gets into a gray zone. Does the gray zone occur when you have 20 people on Mars? Okay. Or is it 30? It clearly, when you have 100, you got to be growing food. Okay.
Do you believe?
Clearly don't.
Do you believe in the probability of Starship fleet? I mean, they're cranking out engines about one per day, and they have the Star Factory. I mean, I looked at
I
Elon's
do
short.
not believe. Okay, look, Musk has accomplished tremendous things. On the other hand, he frequently makes claims that he is going to do things that he doesn't do, or doesn't do on anything like the schedule that he proposes. So you can look at that as half empty or half full, but those are the facts. Okay? In 2019, he said he'd have Starship on orbit in 6 months. Okay? Starship has yet to actually orbit the Earth. Okay? It's very close at this point, but still, it didn't happen in 6 months. It's been more than 6 years. Now, so here's the thing. To the best of my intelligence, there is no comprehensive program at SpaceX to develop the technologies for an actual human expedition to Mars, let alone a city. That is, what they are focused on is developing a transportation system. Okay? And they've done a couple other things, they in spacesuits and so forth, but they do not have an ISRU development program. They assume it will be developed by someone else. Okay, but I mean, it could be once Starship is more ready, then Musk will shift his focus to ISRU because the Musk Mars plan requires ISRU. Okay, on the other hand, if you just want to use Starships to launch Starlink type satellite constellations, then you don't need an ISRU program. Okay, now, is that Musk's real plan? I actually am not so cynical as to say that. I have mixed feelings about Musk. I disagree with his politics, but I will say that he created SpaceX in order to make humanity multiplanetary, and that meant for Musk, as it does for me, the settlement of Mars. Okay, and that things that he's done along the way to make money are like someone crossing a stream by jumping from rock to rock. That he's not doing it in order to jump on the rocks, he's doing it to cross the stream. And the development of the reusable Falcons, followed by the reusable Starship, and the very, well, I don't know how profitable it is, but potentially it could be very profitable, the Starlink communication system, and so forth, that these are rocks that he's jumping on along the way. And in fact, I believe that doing the lunar mission for NASA is just a rock that he's jumping on along the way. And that's despite what he said recently, publicly.
What about NASA developing these surface systems and not SpaceX?
Well, certain ones, yes. Certain, of course, exploration systems, which are very useful in supported settlement. You want to prospect for minerals, this kind of thing. A lot of the sorts of things that NASA does develop or pays to get developed fits that bill. The surface nuclear reactor, that is something really where it would be good if NASA would step up. Okay, so I'm glad that Isaacman is pushing nuclear power. We need it on the surface of Mars. And it would be something rather difficult for SpaceX to develop because space nuclear reactors involve highly enriched material. That is bomb-grade material, in fact. And so this stuff is controlled. And it would be very difficult to develop it entirely. You know, it's not like somebody can just go, and set up in some place like Boca Chica and say, we're going to make highly enriched uranium nuclear reactors and so on. There's definitely a role for NASA here, especially on doing things like space nuclear power that it must be at least a public-private partnership, but clearly the government's going to be involved with. And then also, there are certain things that NASA, to accomplish its science mission, develops that would be very useful for settlement.
Marshall, go ahead.
Earlier, you were talking about NASA proposing projects and other people coming in and wanting to me too it, basically to death, which kind of implies that sometime in the future, the really big projects have to be handed off to standalone companies that can make decisions, decide who can be in it and who cannot be in it, where NASA has to please Congress and all sorts of things. Do you feel that in the long run we have to hand it off to private companies?
Well, in the long run, a lot of it will be handed off to private companies due to the nature of the thing. If needs become apparent and NASA is trying to find the most complicated way to meet that needs in order to make everybody's technology mission critical, there will be people that jump in and say, look, I got a simple answer to this. And sometimes they'll get past the patrons of ignorance and make their point and solve that problem. That happens with some regularity, actually. But if you want to know how I think Mars is really going to be settled, okay, I don't think it'll be done by NASA. I don't even think it's going to be done by Musk. Okay. I think it will be done by people who make use of technologies that are developed by NASA and by especially Musk. But it won't be them. Because it takes a different kind of person to be a settler. And so, but here's the scenario that I see. And I discussed this a fair amount in my most recent book, The New World on Mars. I believe Musk will be successful in creating the Starship, that this will be a workable and successful system. It will cheapen delivering things to orbit, and it can be used as an important flight element within these Moon and Mars programs. And in fact, I believe they'll also find use in intercontinental travel, point to point, anywhere to anywhere on Earth in less than an hour, that kind of stuff. That's all going to happen. But here's the thing. If that happens, it'll be copied. Musk will be not the only person who is making Starship equivalent vehicles. There'll be lots of different types. Right now, there's 5 different companies in China that are working on a knockoff of the Falcon 9. Okay. And if Starship is successful, there'll be 5 different companies in China working on Starship knockoffs, as well as people in other parts of the world. So Starship, think of it now not as the specific Starship design that is going to be made by SpaceX, but as a generic type of vehicle. Okay. Just like, you talk about Kleenexes and Xeroxes, things like this, that were once original, just a brand name, but now become a descriptor for a type of technology. There's going to be these things. Now, the fact that there are going to be reusable launch vehicles means that soon thereafter there's going to be something else, which is a market in used launch vehicles. See, that's not something we've had in the past. Okay, if launch vehicles are expendable, there's no such thing as used launch vehicles. Well, there's going to be used Starships. Okay, and perfectly functional used cars can be found that cost 1/10 as much as a new car. Okay? Everybody knows that. Okay, well, there's going to be perfectly functional starships available for people to buy. They'll cost 1/10 as much as a moon. Okay, and Musk told me on one occasion that he could build the Starship, that is the upper stage, the Starship proper, for 10 million each, which means that either he or one of these competitors would undoubtedly be willing to sell them for, say, 20 million each. Okay, even though that's not SpaceX's current business model, but someone else. And that means that eventually used ones will be available for 2 million each. So let's say you are a leader of some new religious sect, and you and your people, are not viewed favorably by most other people because you've got a new religion. This is pretty much an invariant that this happens. You want to go someplace else. You want to go someplace where the rules haven't been written yet and where you can make your own world. There, let's be new political movement that has perhaps utopian ideas on what the ideal society should be. You would have a place to go, etc. So groups like these, okay, look at human history. Look at people like the Pilgrims or the Mormons or the Zionists who went to Palestine. They're all people of this character, motivated by a need to go somewhere to where they could have their own world. And in many cases, going to places involving real danger and hardship in order to have that degree of freedom. So this possibility will exist. In other words, the technologies will exist. The Pilgrims didn't have to invent ocean-going sailing ships. Okay? A lot of other people before them that eventually created a technology that allowed you to cross the Atlantic Ocean in relative safety. But once it was
Bob?
there, yeah.
Oh, go ahead. I was going to ask you a different
Well,
kind
anyway,
of question.
that's how I think it's going to happen.
A little bit of offbeat question. I know your nuclear background, and I'm really hoping you can clarify or at least give us your perception. Is America, both from a regulatory point of view and a cultural point of view, opening up and getting ready to embrace nuclear power for terrestrial uses, for grid uses in the country? Is that starting to look like, from your perspective, that it's going to be doable, or is it still fear-based and out of reach?
No, I actually think we are on the beginning of a nuclear renaissance, and not only here but in Europe. In fact, what's her name? This woman who's kind of like the head of the EU. Anyway, she gave a speech the other day in which she said, our decision, we were previously 30% nuclear, now we're 15. This was a grave mistake. Okay. And why did she say that? Well, there's two reasons. One of which, somebody realized that Russian oil is not carbon free. And the second is the lack of prudence in being dependent on Middle Eastern oil, as illustrated by current circumstances.
Her name was Wanda Luyan.
Yes, that's the name. Exactly. She gave this speech, and she had been one of these people supporting the abolition of nuclear energy not that long ago. She now says this was a mistake. And in light of both the desire to decarbonize, but also now the clear danger of making oneself dependent on fuel supplies that either come out of a region of the world that is a powder keg or come from a country that wants to conquer you. And the fact that the so-called renewables, I call the unreliables of wind power and solar power, haven't measured up to the claims of those who say they could decarbonize using such technologies. And that has proven to be.
She's actually German, of German descent, and she
Right.
criticized Germany for what they did 10
Right.
years ago. You know,
Yeah, well, what they did was just nuts.
it was nuts. Yeah.
Bob, can I ask a question back to Mars? So I'm wondering about, like, again on Mars Direct, if you have a present day dollar value for, say, per mission using Mars Direct, is that a number that you've calculated or somebody's calculated? And if so, can you share it with us?
Well, actually, I believe the cost for a Mars Direct type mission would go down now because of Starship. You know, we were looking at a couple of billion per mission back then, and that seemed like, well, it was a real bargain compared to what NASA plans were, which involved building gigantic nuclear electric spaceships at orbiting spaceports that had to be built and all this stuff. But, you know, okay, look, if Starship is successful, you know, I myself, okay, you could refuel Starship, send it one way to Mars, or you could refuel Starship and send it to Mars orbit and be the refueler for Starboat, or you.
Well, let's not talk about Starship, because that's not like something you can hang your hat on yet, because Elon makes all kinds of predictions about what it will cost, what its payload will be. We don't know what those numbers are yet, but we know for other programs, other rockets, what they are, like Falcon Heavy or SLS.
Yeah,
we have numbers for that.
I think it's pretty clear that Starship is going to be considerably less than $1 billion a launch. I think we're talking 100 million. So what if it's 200 million? That's still much less than $1 billion. Okay, they haven't reached orbit yet, but they have almost reached orbit. And
I mean, let's just base it on what we really know.
Look, yeah. I have rather mixed feelings about Musk and his pronouncements and his politics and all that, but he's got the best rocket team in history working for him. He really does, and he deserves a lot of credit for having built that team. That's real. That's real, and they may encounter further problems, but a crack team like that will solve the problems. So I do believe that this thing's going to work. It's going to be successful. I do not see anything fundamental in the design or in the physics of it that says it won't work. I mean, even if they have to make the upper stage expendable, so what? In other words, what if the Starship just turns into a 5X sized Falcon 9, which is what it would be if you made the upper stage expendable? That's just gigantic. Reuse the big lower stage. I mean, look what they've done. I mean, really, they're launching 3 Falcon 9s a week. That is 150 a year. That's not a promise. That's actually happening right now. 150 Falcon 9s, right, and reusing them, and the first stage of them. And, you know, the shuttle, NASA hoped that they could do 40 a year. The best they ever did was 8. Okay. They averaged 4. Okay. The SpaceX right now is launching almost as many Falcon 9s in a week as NASA averaged shuttles in a year. And so this is a very competent team. Okay. And, you know, that part is true. Okay. It is not true, as Elon Musk claims, that 15 years from now, you won't need money. Okay. So don't take his advice on that. Okay. He doesn't take his advice on that. You may have noticed. So yeah, he says a bunch of things that are fantastical, but Starship's going to work.
What I was trying to get you on the record was just like, what is the cost of a Mars Direct mission, not with any speculation integrated into the plan, but with absolute known vehicles that will definitely work and definitely have a price on them right now?
Well, look, SLS is the Ares vehicle that we designed for Mars Direct. Okay, now you got to understand that. Okay, we designed that in 1988. Okay, and we didn't design it as if we thought this was some futuristic miracle. We designed it as a simplification of the shuttle launch stack. Okay, it took NASA to turn that from a 4-year project into a 35-year project. Incredible, and not even meet the specifications that we had laid out, because we put a J2 on that upper stage. But no, there's no question that there's been entropy in NASA. Okay. And there's also no question that, on the other hand, SpaceX has greatly overperformed relative to, well, certainly any standards in the space industry post-Apollo, and arguably during Apollo. But but here's the thing. Look, there's a lot of pathologies in NASA. There's pathologies in the military. There's pathologies in the post office. All organizations have them because they're composed of people, and the individuals within these organizations have their own interests, which are not necessarily aligned with the goals of the organization. Okay? Every individual in an organization wants to be needed. The need of the organization is to have as few of them as possible to be needed. That's just how the cards are cut, right? But nevertheless, given that imperfection and fundamental contradiction, NASA has accomplished incredible things. If Isaacman actually does his Mars helicopter mission, if he gets off of his need to impose space nuclear power on it, because that's what it is, it's an imposition, okay, and just does it the easy way, he'll have a great mission. It'll be in the books as one of the great episodes of NASA's exploration program. If he does rationalize Artemis and turn it into something that can do efficient lunar missions leading to a permanent lunar base, that'll go in the books. But these things require clarity and vision, and engineering decisions need to be based on truth. They can't be based on bullshit. And that is a problem with trying to make this administration in particular the engine for accomplishing these things, because they're not long on truth.
Yeah, if I may ask, you mentioned Falcon 9, of course, obviously that's been extremely successful. So has Falcon Heavy, of course, obviously, which is made up of Falcon 9. In my calculations, I see that the reason why, and I did some calculation using Falcon Heavy to go to the moon surface, etc. What I noticed is that the upper stage of Falcon, of any reusable system, has to be very low dry weight or empty weight, whatever you call it, inert weight. And the problem with Starship is just like 85 to 100 ton inert weight or dry weight or whatever. And so that's just nonsense to use that for going between LLO and surface and up. So you came up with the Starboat idea. What about the idea of just simply making the Starship upper stage like 1/5 the size. There is no need to take 100-ton for moon to Leo. There is really no need for that. It can be done with, we can do with much less, maybe 20-ton payload, 30-ton payload to Leo, something like that, and design the upper stage, which would have, because obviously comparatively, obviously correspondingly lower upper stage weight,
Yeah.
dry weight.
Well, what I would do,
Yeah.
the obvious answer here is a third stage. And if you had if you think of the current Starship configuration as being able to deliver 100 tons to low Earth orbit, what if that 100 tons consisted of a vehicle with a dry mass of 20 tons and the rest was propellant, 80 tons?
Well, I know, but the dry weight of the upper stage, dry weight of the Starship will still be 85 to 100 ton,
Yeah,
which is unnecessary to take it to the moon.
But I wouldn't take it to the moon. You're not listening to me. Let me explain again. Let's say your configuration was you have the Starship more or less as currently designed, but it lifts to Earth orbit a vehicle that has a dry weight of 20 tons and 80 tons of propellant. That's the 100 tons it brings to orbit. So that goes to the moon. Mm-hmm. Right? So yes, you could launch your Starboat, if you will, from low Earth orbit, being lifted up to Earth orbit, fully fueled by the two-stage Starship, which stays in geocentric space. So there it is. You're just creating a third stage on the two-stage vehicle. And it's the third stage that goes to the moon or Mars. And I proposed this to Musk, and it's basically a variant of the Starboat approach. He wouldn't listen. He says, I only want to develop one thing. Okay. NASA, if it says, well, if you can give me Starships, there's this, I need a payload for it that is this. And they should put out an RFP and say, we need Starboat. Who wants to build it? This is what it has to be. Mm-hmm. It has to be way no more than this. It has to run on methane oxygen. It has to, be interoperable with Starship, mm-hmm. and so forth. Yes. But that's precisely it.
Yeah, so except for methane oxygen equation, the Mark II of Blue Origin, which is 45 ton, could that be the payload of Starship?
I'd have to look at that. I don't know. It's worth looking at, but I can't answer that just simply.
Yeah. Okay.
Everyone, we're moving toward 90 minutes for our show. So if you have closing comments or final question, or Bob, if you want to go longer, or if you have something that we talked about.
Well, no, I can't go longer, but I do want to mention a couple of things. Number one, we're going to have another Mars Society convention. It's going to be in Los Angeles in late October at University of Southern California. Same location it was at last year. They've got excellent facilities there. And, well, that's what's happening. And I believe we actually have posted the call for papers and the exact time and place on the Mars Society website already. So people, if you have ideas on something you want to present, send in an abstract. Okay. So that's number one. Number two, one of the questions was, is NASA or SpaceX developing the technologies for Mars settlement? The answer is not really. They're developing some of the technologies needed for Mars travel, yes, but not for settlement. And this is why the Mars Society has launched the Mars Technology Institute. That's its mission, to develop the technologies needed not to travel to Mars, but to settle Mars. Okay, because you see, a place becomes habitable if you can turn the materials there into resources. There's no such thing as natural resources. There's only natural raw materials. They become resources when someone develops the technology that can transform them into useful form. Okay? You know, the first 4,000 years of human civilization, people only used metals with low melting points, including copper, tin, zinc, lead, gold, silver. They could not use iron because they couldn't make it. And these low melting point metals that I just mentioned collectively are 100 parts per million in the Earth's crust. Now, some of them get some local concentrations due to certain geological phenomena, which is why people were able to find usable copper ore. But it was rare, expensive, and metals were really only available for artistic things or for armor for aristocrats. They were not available for everyday use items. However, around 1400 BC, the Hittites developed kilns that were hot enough to smelt iron. And iron is 50,000 parts per million in the Earth's crust. So as soon as that invention became widely practiced, the amount of metals available to human civilization increased by a factor of 500. Okay. Later on, okay, aluminum is not known to science until 1820. Okay, because there's no naturally occurring aluminum metal on Earth. There's aluminum oxides, which are generally known as rock. But no one even knew this stuff existed. And it didn't become in common use until the 20th century. Now it's so common we make soda cans out of it and throw them away. But there it is. And then more recently, of course, silicon and titanium and various interesting properties. If you could sit in on a meeting of the general staff of Napoleon Bonaparte and they were talking about conquering some country and what resources they would get by doing so, oil would not have been on the list. Oil was not a natural resource for people in Napoleon's time. It was occasionally observed as an annoying pollutant that came out of the ground and ruined a farm. But when oil drilling and refining and engines that could run on the product were developed, it becomes a critical resource of the earth. Uranium, of course, not a resource until we invented nuclear power. Deuterium, not yet a resource, but will be once we develop fusion power. Similarly, there's all kinds of stuff on Mars that are not resources yet, but will be once the technologies are there to turn them into resources. And this is the goal of the Mars Technology Institute. And if the kind of substances that exist on Mars, which generally are not viewed as resources on Earth, become resources, you're going to greatly expand the resources available to humankind. Okay? And you'll also disprove the thesis that we do face a future of limited resources that we have to fight over, which is also extremely important to do. So I hope people will look into the Mars Technology Institute, perhaps donate to it, perhaps participate in it. Because the challenge of settling Mars will create technologies that will radically expand the prospects of the human future.
Absolutely. We could clap and the audience could hear it. I'm sure all of us would do that. Bob, thank you very much for coming back and being on the space show. And I hope a lot of people hear what you're saying and take it to heart and can find a way to act on it, especially with NASA science budget and some of the things we talked about early in the program. And look forward to seeing you and hopefully I can get over to LA and attend Mars Society this year. I look forward to it.
Okay.
Thank
Thanks for having me on the show. Thanks for all the good questions. And I'll see you on Mars.
Absolutely. Or USC, that might be easier. I don't know. So,
Okay.
thank you very much, Bob.
Okay.
Everybody,
Right.
good night. And as we like to say, keep looking up. And goodbye from John Hunt and Phil Swan and Marshall Martin and Doug Plata and Sherry Bell. And AJ has already left the stage. Once again, good night, everybody. And our next live space show is on Friday morning with nanotechnology with Dr. Rao, R-A-O. You can read about him on the Space Show website.